Electricity is everywhere. It powers your house, your fridge, your phone, your car, and now your solar panels and batteries. But here's something that some people don't realize. There's two different types of electricity, and they've actually been competing for over 100 years. So what's the difference? And why do the two of them exist? So welcome back to the lab where our opinion cannot be bought. As you guys know, we don't only exist to give you honest feedbacks and save money where you can, we also want to make solar easy for you guys so you can gain energy independence without needing an electrical degree. You can support us for free by subscribing. But before we explain to you guys the importance and why you should know the difference between AC and DC, we're going to go into a brief history lesson. In the late 1800s, electricity was the way of the future, but people didn't agree on how it should be delivered. On one side, Thomas Edison was pushing DC current, direct current. On the other hand, Nikola Tesla, backed by George Westinghouse, was pushing alternating current, AC power, and this rivalry became known as the War of Currents. Edison had already built DC power stations. DC was predictable, simple, it worked well, but only over short distances. Tesla's alternating current was less understood and riskier, but it had one massive advantage. It could be stepped up and down in voltage using transformers. This solved the problem that DC had. You could send power long distances. And this wasn't just about engineering. It became political, financial, and even personal. This led to Edison trying to publicly make AC look extremely dangerous compared to DC. He staged demonstrations and even supported the electric chair using AC to scare the public. This is where that famous story comes from, where Edison's company filmed the 1803 execution of Topsy the elephant. He used alternating current in Luna Park, Coney Island. So as we said earlier, the problem with DC power is that we couldn't send it far. DC loses voltage rapidly over long distances. To compensate the voltage drop, you need very thick copper wires, power stations every few miles, and that would lead to massive infrastructure costs. And that's when AC solved this problem. With AC, you can transform the voltage up to transmit at long distances with very little losses. And you could also step the voltage down near homes, so it's much safer to work on. And that one ability made AC vastly more efficient for national power grids. So by the early 1900s, AC became the standard for cities, utilities, and transmission lines. And DC lost the war, at least on paper. So you've probably heard this, that it did in fact lose the war, but most things that we do use today actually still use DC power. It's a little bit confusing. So we're gonna explain how DC and AC actually work. First up, DC, direct current. Electricity flows in one direction. Imagine water flowing steadily through a pipe, or using a battery with the positive and negative terminal, the power is gonna exit at one side, flow through the wire, and then back to the other. With AC, alternating current, the electricity changes directions and it moves back and forth. In North America, it oscillates 60 times per second. This is where 60 hertz comes from. To visualize this one, imagine waves in the ocean. The water's not actually moving anywhere or getting transported to a different location, it's just moving back and forth. A really simple way to understand this with the electricity is imagine you have DC power, you're running it one way in one direction, you flip a switch and it sends it the opposite way. Now you're flipping that switch 60 times per second, so it's moving back and forth really fast. The way that the power moves back and forth is actually what allows the transformers to work. Neither one of them is better than the other, they're just optimized for different jobs. But wait, you've heard that AC won. So if AC won, why are solar panels and batteries DC? Why does nearly every electronic device run on DC? And this is where things get interesting. Solar panels naturally produce DC. Batteries can only store DC. And electronics like your phone require stable one-direction power. But you might be thinking, well, you're plugging in your phone into your wall socket, which is AC current. You're plugging your TV into your wall socket, which has AC current. The thing is you've seen those little bricks on those power cords, or the brick that you use to charge your phone. That's actually a little mini transformer. It's taking the AC current, turning it back into DC to then power those devices. So AC powers your grid, but DC quietly took over almost everything else. So AC is amazing for powering the cities, transforming the voltage up and down to transport it long distances, but once it's locally in your home, DC is sort of the king. But not every device is using DC. Things like resistant elements, a toaster, a space heater, those things are going to be using alternating current still. And for a quick example of the things that are DC, phones, laptops, cars, power tools, LED lighting, solar, batteries, and apparently from our research, entire data centers run on DC. So this is why understanding AC and DC matters. If you're running any of these devices, you're living in both the AC and DC world. So next time that you hear someone say that AC won the current war, you'll know the truth. DC did not disappear. It's still sort of a backbone in modern energy. So next time you're thinking of setting up your solar power system or how you can optimize your power, remember this: you're going to be taking power or generating power from either DC or AC. And if you need to do a conversion, you're going to be turning one of the power types back into the other, or vice versa. You're going to most likely be inverting it to AC. Your inverter uses the power from your power stations to create that process. Remember when I mentioned the switch back and forth 60 times? That takes energy to power that. So if you're going to be using something like this and you need to just charge your phone, plugging it into the AC outlet doesn't make any sense at all. You're basically taking DC power, converting it into AC, then converting it back to DC. Your most efficient way is going to be plugging it into one of these DC ports. I actually didn't realize this one of the first times that I was setting up my own off-grid system. What I had was a power station with an AC outlet. I had an extension cord plugged into that. I then had that running all the way out to a shower location where I had a DC pump. I then used one of those mini DC inverters to convert the AC power back to DC when I could have just simply plugged in a DC cord and ran that straight out to it. So that entire time that I was powering a DC pump, I was actually using the AC inverter when I didn't have to. And it drained my battery way faster than if I just had DC to DC. So I hope that simplified things for you guys and you won't make the same mistakes that I did. That's all we got for you guys today. Thanks so much for watching. We'll see you in the next one. Peace out and stay charged.